create a new variable and how to record the variables, how to calculate the frequencies and descriptive statistics. And at the end of the session, we will cover all types of hypothesis testing. Okay. So now we will walk through SPSS first, then we will explore one by one all. Okay, so let me open the SPSS. My screen is visible.
Yeah, it's coming.
Okay,
Yes, now it's visible.
okay, so some of you might already know about SPSS, but for those who are completely new to SPSS, so let me give you a quick tour about SPSS. So this is the now we are in the SPSS software. This is the SPSS interface looks like. So here you can see there are various menu one by one like file, edit, view, data, transform. So let's explore one by one. So first one is file option. You can see this is the file option. So if you click on the file option, you can get those types of options are there like new, open, import data, general, open. Okay, so basically you have when you want to import your data, you have to go for this file option, and then you can find two options is there to import your data, like import data and open. Suppose you have a, Excel data that is downloaded in your device. So for that you have to go for this import data option, and then im- under the import data, this is the file type. You have to choose the file types. Like I'm choosing here CSV data. So this is the all the CSV data that are downloaded in my device. Then you have to select any of those, and you have to click on open. But IBM itself provides some sample data for your practice purpose and all. In this demonstration, we will import a sample data, and we will analyze on that data set, on that sample data set. Okay. So those types of sample data are available in your device only. So let me show you how you can access those sample data. So for the sample data, you have to go for this open option. Okay. So basically when we import a sample data, then we have to go for this open option. When we want to import our own data that is in my device that is downloaded in my device, so then for that you have to go for this open data import data option. Okay, so now I am going to open such the sample data. So let me show you how you can access those data sets. So you have to click on open, and then you have to click on data. Then these types of interface will come to you, and in the looking tab you have to select local cdx. Please have a note. So first you have to select local cdx, and then after that you have to select the program files. Here is the program file. Looking tab, under the looking tab you got the you will be given the option as program file. So you have to click on the program files. Under the program files you have to select this IBM option. Okay, then you have to select this SPSS, sorry, SPSS statistics I have to select. Under the IBM option you have to select the SPSS statistics. Then you have to select this sample files. Under the sample files you have to choose the language of your data. So that is English. When we choose the data, you have this you have got this data set, this all the sample data set that is provided by SPSS, IBM SPSS, for the practice purpose and all. So suppose I want to import this demo data set. So for it I have to select the demo data set and I have to click on open. In just few seconds you can see we have successfully accessed the demo dataset. So this is the demo dataset, demo.sav. So at the moment you install the SPSS in your device, so these datasets are get automatically installed in your device. So no need to worry about it. You can found it on the local CD, and the step by step you have to follow that. Okay. So here you can see uh, under the data and trans next option is data and transform. One more thing, under the file option, one more option is there, recently used dataset. So if you want to import recently used dataset, you have to go for this recently used dataset and you have to click on any of those, whichever you want. Okay.
Hello?
So there is, yes
Ah,
sir.
ah, நானே
Hello.
பேச முடியும் நானே பேச प्रदोष में केवल बस वो मार देना
Hello.
Rachinder
हैं
ji, mute your, Rachinder ji, please mute. Rachinder ji,
Okay.
sir, you can continue now.
Sir. Okay. So under the file option, you can got this recently used datasets option. So from there also you can import those types of recently used datasets. So next option is data and transform. So basically, before jumping to the actual analysis, you may want to pre-process your dataset. So under the base module, here you can perform basic data pre-processing technique using this data and transform option. So under the data option, you can see those types of options are available. Under the data option, you can apply some filter, or you can sort the variables, you can sort the cases. Okay, so suppose you can apply the filter. Suppose you are working with this data set, so this is the demo data set, and you can see there is a age column. And suppose you want the people whose age is less than 45 years old. So for that you need to apply some filter on the data set. So you can apply the filter on the dataset by using the case select cases option. Under the data option, you can find this select cases. Okay. So when you click on the select cases, and you have to apply if condition here. When we apply the if condition, the filter will be applied. Okay. In the later in the session, I will show you. So by select cases, you can apply the filter from the data option. Like in transform, suppose you can get those types of options are there, like compute variables, count variables within cases, recode, automatic recode, all types of options are there. Suppose you have a categorical data, like in these datasets you can see gender variable is there, but the gender variable, the data of the gender variable is collected as a string format. That means S and M. So for the further analysis, we need to decode the variable. That means string to numerical variable, like female to 1 or male to 0, like this. So we need to recode the variable. So for recode the variable, we have to go for this transform option. So under the transform option, you can get this recode option is there, recode into same variable and recode into different variable. Okay, those two types of recode option is there. When we click on the recode into different variable, that means a new variable is created at the end of the all variable, and the recoded version will be there. Okay, so when we click on the recode into same variable, that means in the same variable the recorded version will be there. So like this, you can record any categorical variable that is in string format. Okay, using this transform option. So next one is analyze option. So this is the main and very important menu where all types of analysis are available in the analyze menu. Okay, that is provided by SPSS. And next one is graphics. So under the graphics, you can see all types of visualization technique are available. Okay, so next here you can see at the bottom left corner there are three views are there. That is the new features of version 31. Okay, that is overview, data view, and variable view. So when you click on the overview, as the name suggests, it will give you the high level idea about your dataset. Okay, so you have to click on this update option. Update as option will be there, and when you click on the update option, the interface will update it according to your imported data. Okay, so here you can see this is the measurement level. That means it is showing me the information about my variable. That means we have the data where 86.2% are scale variable, 10.3% is ordinal variable, and 3.4% are nominal variable. Okay, so basically this is showing me the information about my variables, and this is the summary of missing values. So you can understand that it is showing me about the missing value information and idea about the missing value. And that means 3.4% variables are missing. The red one is incomplete data, that means missing, and blue one is complete data. So for the variables, 3.4% variables are missing, and for the cases, that means observation, that means 4% observations are missing out of 100. And if you consider the value, that means 0.1% values are missing. And this is the variable report. It's very important view in SPSS, because you can see there is a drop down menu. So if you click on the drop down, you can get the all variables that is in your imported data, that is available here. Okay, suppose you want to see any if you want to see any distribution of the continuous variable, so you can check it from here also. Like I want the distribution of income variable, so I have to select the income variable. So I can see this is the distribution of the income variable that is in my data. So without writing any types of code, you can get the just by one click, you can get the frequency percentage, or you can say the histogram plot of income variable. Okay. Mm. And this is the descriptive statistics of that variable whichever you selected in the drop down. That means by one click you can get histogram, and also the descriptive statistics of the income variable. That means missing value is 0, valid cases are 6400. This is the mean, standard deviation, maximum, minimum, percentiles. Okay, so all types of central tendency and dispersions are available, that is selected in the drop down menu. Okay, if you select any categorical variable, then you can get the bar plot. So this is all about overview. Next one is data view, where you can see your imported data, that is data view. And this is the variable view. It's very important part in SPSS, because here you can select the,
लोग कैसे जुड़ पा रहे हो
sir,
डायरेक्ट लिंक पे जाओ
sir, please mute yourself, sir. I request to all of you, please keep on mute, sir, so that everyone can experience a smooth session. Okay, so this is the variable view, and in the variable view you can see this is the name section. If you want to add any variable in your data sets, so first of all you have to write the variable names here, and you have to put the all information about the variables. Then it will be created in the data view. Suppose I want to add one more variable at the end of the variable, so from there I can't do anything. I have to go in variable view. Then at the end of the variable, all variable existing variable, I have to write the new variable name, and I have to put all the information. Then it will be created in the data type. Okay, so this is the name section, but putting when we put the name in the for the variable in this variable view, so there are some certain restriction, because you can't use any special character, or you can't use any space by putting the names. So for that you have to go for this label option. Okay, so when you go with the label option, those types of restriction are not there. You can put the variable, you can put the name of your variable as per you want, so in the label option. Okay, and this is the values option. So it's very important part in SPSS
मुझे पता है क्या
when
हो रहा है
when you
हो रहा है ना हमारा हम रिक्वेस्ट करेंगे कि आप हमें रिकॉर्डिंग सेंड करो
hello.
Participant, participant, please mute your mic. Participant, thank you.
जल्दी आओ
When we put the when you have a categorical variable, and you
Participant, please mute your mic. Anjali, please mute your mic. Thank you.
So when you have a categorical variable, and uh, I have a gender variable, and I am recording it into some number like 0 for male and 1 for female. So 0 and 1. Then how do a third person came to know that what is 0 and what is 1? So for that you have to add some label on the recorded version, like 0 for female and 1 for male. So for that you have to put some labels on the values. So you can go with this values option, and then you can add some label on the categorical sorry, on the recorded version. So for that the values option is there. This is the missing value information, and this is the measurement. It's very important. Sometimes it happen that SPSS automatically indicates those automatically identify the variable measures, but sometimes they do some mistakes. So for that you have to change. There is a drop down menu. Just 1 minute, sir. So there is a drop down menu. From if you click on the drop down menu, you can see scale, ordinal and nominal. If it is scale variable, that means continuous variable, then you have to choose scale. If it is categorical but there is some order like first, second, third, okay, so you have then you have to select the ordinal. And if it is a categorical variable but there is no ordering, like male and female, there is no order, so for that you have to select nominal. Okay, so like this you can change the variable measures from here. And this is the role. Okay, and this is the variable type. Okay, you can change the variable type also. Here three horizontal line is there. If you click on three horizontal line, then you can get the all variable types that is provided by SPSS, like numeric, dot, comma, scientific notation, date. Okay, so if you want to change any variable type, you can do it from here by clicking the three horizontal line. So like this you can manage the variable. It's very important part before the analysis, mm, to manage the variable view. Okay, so this is all about SPSS interface and basics. So now we are moved to the actual part of our session, that is data preparation. So in the data preparation, first of all, I have to apply some filter using select cases. Okay. So suppose this is my data sets, and I want, as I told you earlier, that I want those people who are only 45 years old or less than 45 years old. That means less than equal to 45 years old. So I have to apply some filter. So how do I came to know that how to apply the filter? I
Excuse me,
have,
Papu sir.
yes sir.
Sorry to interrupt you. Sir,
Hmm.
in between, please also check the chat also. So there are a few questions.
Sir, it is not possible to check the chat repeatedly. At the end of the
Okay.
session, we will cover all the things. Okay, sir?
Okay, fine. That's fine, sir.
Okay, sir. Okay, sir. At the end of the session, we will try to answer all the queries. Categorical. Categorical variable means that is not in numeric form, like not is not not in numeric form. That means I we have a variable like gender variable. Gender variable is not like that. Age and gender, compare the age and gender variable. Age is numeric and gender is male and female. It's not a numeric like continuous measure. So for that it is a categorical variable. So categorical variables are two types of categorical variables are there. First one is ordinal, and the second one is nominal. Okay. Ordinal means this is a categorical variable, but there are some orders like first, second, third, first rank, second rank, and third rank. This is also a categorical variable, but there are some ordered first, second, and third. And the gender variable is also a categorical variable, but there are no order. But there are no order. So this is the if it is gender variable, then we choose nominal. If it is like position or like this variable, so there are some order, then we choose ordinal. So for this basic statistics, you can use Gun Das Gupta, Fundamental Statistics, Volume 1 and Volume 2. Okay. Uh, okay. So we need to apply the filtering. So in the data option, you can get the select cases option is there. You have to select the select cases, and this is the all cases. Okay. So all cases means you consider the all cases. There is no filter. If you click on if condition is satisfied, and that means there is you can apply the filter. Okay, so you have to click on the if condition, and when we click on the if condition, then those types of interface will pop up like here. Okay, so here you have this is the condition box. You have to write the condition, and then you have to apply it. So I have to write the condition, that is we want those people who are 45 years old, less than 45, less than equal to 45 years old. So I have to put the age variable here, age less than equal to 45. So this is the condition, and I have to click on continue and OK. In the data tab, you can see those data points are discarded which are greater than 45 years old. Okay, and those data points are remaining data points which are less than 45 years old. You can see here some of the data points are discarded from the actual data set. So like this you can apply the filter. If you want to remove the filter, you have to go for this data option and select cases, and you have to choose all cases. Okay, then you have to click on Okay, you can see all cases are included. So let me repeat once. When you apply some filter, then for that you have to choose select cases and if condition satisfied, and you have to write the condition here in condition box using this virtual keyboard and click on continue. Click on OK. Like this, you can apply the filter. When we want to remove it, you have to select all cases. Okay. So this is all about filtering. So next one is sorting cases. So sorting means organize the data for the better visualization, like ascending order or descending order. So when we sort the income variable, that means we want to check the most rich person, or we want to check the lowest income person. So for that we like this we can apply the income variable here. Income variable is here. We have to apply the sorting in income variable. So in data option you can see short cases option is there. So if you click on the short cases, and this is the all variable, so from the all variables I have to choose the income variable. So this is the income variable category and this is the income variable. I have to choose it here, sort by variable box, and then I have to choose the order, that is ascending or descending. I want descending, so I have to select the descending and I have to select the OK. So you can see highest income is this and the lowest one is at the end of this data. Okay, so this is the lowest one. So like this you can sort the variable by using the sort case option. Under the data option you can find there is a sort case option is there. Okay, so next one is handling missing value. Okay, so sometimes you can find there is some missing value in your data sets. Okay, so you need to impute it, or you need to delete it from the from your.
Yeah.
Yes, sir.
Abhinay Gautam ji, please mute yourself.
So missing value can skew the result if it is not ignored. Okay, so if it is ignored, then missing value can skew the result. But when we replace the missing value with the mean, median, and mode, then we can get a better result. So we need to impute, or we need to replace the missing value using SPSS. Suppose we don't have this data set. Just 1 minute. Suppose this is the missing value. Okay, so this is the missing value, you can see. So this is the missing value. Now we have to import or replace the missing value using SPSS. So how do I replace the missing value using transform? So under the transform, sorry, under the transform option is there. Under the transform you can find there is a replace missing value option is there. Okay, replace missing value. So first you have to select the replace missing value and you have to write the variable's name here. Sir, please mute yourself. 501. Replace missing value. Then I have to select the income variable. So this is the income variable. So I have to put it here in new variables box. So this is the method. Okay, so we can see highest those types of options are available. Okay,
तो सिलेबस कैसे
in
कवर होगा?
SPSS to sir, please mute yourself.
बेसिक था, सो यूट्यूब में लेक्चर देखा मैं, बेसिक अंडरस्टैंडिंग था उसका।
बैंक पेपर दोबारा देने हैं, तो बैंक पेपर भी दोबारा देगा।
The participant, please mute yourself. Dell,
बैंक पेपर दोबारा देगा? ना ना ना, इससे बैंक पेपर देने दोबारा अच्छा।
Papu ji, can you mute on your behalf?
20 नंबर है
No
इसमें।
sir, I can't.
Because you have admin rights right now.
नंबर लेके आई,
सारा खराब कर देगा।
Madhusudan sir, are you there?
नंबर लेके आई।
तो फीस रसीद कर जाएगी सुबह आते ही।
Hello sir.
नहीं कटेगा तो क्या होगा?
नहीं है ना, मैं बना के लाऊंगा
मैं इसमें कर
ढंग
दूंगा,
से
कल के दिन
सोमवार।
कोई बात होगी टेक्निकल।
Now participants, please mute yourself.
5-7 नंबर आएंगे इसमें, नहीं आएंगे?
अरे मुकेश कुमार, मुकेश।
ये जो एनसीसी वगैरह सेकेंडरी चीजें नहीं है, मेन आपका काम, अगर मैंने कम नंबर दे दिए ना तो फिर आगे को बहुत दिक्कत आएगी। अभी शुरू शुरू में कहा
Mr. Dale,
कि आपने इंटरव्यूटर का से
Imran,
Mr. Dale,
make me co-host now please.
नेक्स्ट राउंड से
Make me co-host.
कोई सीधे बोल रहा हूँ, जरा उसी के अनुसार बना के ये मैंने यहाँ रख दिया, इसको रखा है मैंने, सोमवार को लाओगे ठीक है, नहीं तो इसी से चेक करूंगा। ये
Mahanta ji, can you
बदल
make
के लेते याद रख,
me co-host so that
ठीक हो तो तुम्हारा भविष्य बहुत उज्जवल है, उसके अनुसार बना के लाओ। मैं सबको नहीं बोलता हूँ ऐसे, ठीक है, आप कर सकते हैं, इसलिए नंबर दूंगा, किस में दूंगा, ऐसे में कोई कॉपी खुलवाएगा तो दिक्कत आ जाएगी। लोग बहुत अच्छे अच्छे मेहनत से बात करते हैं, वो देखो पिछले साल में अच्छे से बनाते।
सर एक व्हाइट पेज और देना।
नहीं है व्हाइट,
दे दो सर।
सही में नहीं है, मैं झूठ क्यों बोलूंगा।
Hello.
yes, sir.
Okay. Can you hear me now properly?
Yes, we can hear you.
Okay sir. So sorry for the disturbance. So we need to replace the missing value. So this is the method of the imputation. Okay, that is available in SPSS like mean, median, linear interpolation like this. In the base module, we can replace the missing value by the simple method like mean, median, mode like this. But there is a separate module that is missing value module. So if you purchase those modules, then you can get some better methods like regression or like machine learning algorithm to impute the missing values. So basically here you can see this is income variable is a skewed data. That means the difference between highest and lowest is too much. So for those types of cases we use basically median. Okay, median by the nearby point. So I have to choose here median. We can use this mean by nearby points also, but we choose here median for the better result, because when we choose mean, that means it will calculate the whole series mean and it will get the result. So it will give the result as whole series mean, so it is not appropriate for our analysis. So for the missing value imputation, if we have some categorical data, then we have to choose mode. That means if we have some categorical data like gender variable and one gender variable is missing, then we'll use mode. If we have some continuous variable, but the continuous variable is distributed normally, then we simply choose mean. And if the categorical variable is sorry, if the numerical variable is skewed, not normally distributed, then it's better to choose median. Okay, then you have to one more thing, when we apply this analysis, that means missing value imputation analysis on our data set, that means a new variable will created at the end of the all variable, and the imputed version of the missing value will be there. Like if I click on OK, in the data view you can see there is a missing position is there also, but at the end of the end of the variable a new income variable is created, and this is the missing values. So here you can see this is the missing position, and here we imputed the missing values, okay, by using mean, because this is it's not a good result because our data set is highly skewed, left skewed. So for that median is also not predict well. So this is all about missing value imputation. So for the missing value imputation you have to click on transform. Under the transform you can see replace missing value option is there, okay. So using the replace missing value option you can import the missing value from here. So next one is compute variable. Compute variable means a new variable, to create a new variable from the existing one, then we have to compute the variable, we have to go for this compute variable option. Suppose we have three exam scores, like exam 1 score 1, exam 2 that is score 2, and exam 3 that is score 3. Now we want to add all the scores, and we want one variable as a sum of three scores, okay. So there are three column, basically there are three column, and we want the sum of three column in one column. So for that we have to go for this compute variable option. So let me open SPSS. So in the analysis, sorry, in the transform option, you can see there is a compute variable option is there. You have to click the compute variable option, and you have to write the condition. Like for this variable, suppose I want to add age variable and income variable. This is not significant, but for the demonstration, I will show you. Like I want sum of age and income, okay. So this is the target variable, that means new variable, and we have to write the numeric expression. So first I have to put the age variable, so I am selecting the age variable and I have to drag it here, then plus any types of operation you can do it from here. So I have to select the income variables and I have to drag it here. So age plus income, that means a new variable will created at the name of sum of age and income, okay. Then you have to click on OK. There are some restriction by putting the name of the variable, because we can't use any special character or space, so we have to remove the space by putting the name of the variable, okay. So you can see at the end of the variable one new variable is created, and this is the sum of income variable and age variable, okay. This is the sum of income variable and age variable. So like this you can compute variable and create a new variable. So for the compute variable you have to go for this transform option and compute variable. So next one is recode variable. So recode means suppose we have a data set, have a categorical data sets. You can see in the data sets. So in the demo data sets here, here this is the gender variable, and the data of the gender variable is collected as the F and M format. that is string format. So for the further analysis, we can't use any alphabetically expressed data. That means string variable. We can't use any string variable. So we need to recode the variable. We need to decode the variable into some numbers. So for that, then we can use it in our analysis. So for this is called recoding. So for the recoding, we have to go for this transform option, and in the transform option, two option is there. As I told you earlier, if you select the decode into different variable, so I'll show you one by one. So first you have to select recode into different variable, and those types of interface are came to you. So I have to put the variables first. So this is the variable list, and this is the gender variable. So I have to put it here, gender variable, and I have to write the name of output variable. So I'm putting the name as gender record. Gender record. Okay. This is the level. If you want to give some level, you can do. You can give from here. Then this is the old variable, and this is the new variable. Then we have to define the old and new values. Okay. So this is the old value and this is the new value. So in the data sets we can see the data set. In the data set we can see F and M. F means female and M means male. So this is the old data. So as I mentioned, F is the old value and we recorded it as 1. That means females are recorded as 1. So I have to put it here. So I have to click on add, and the next old value is M, and the new value is 0. That means males are recorded as 0. So I have to add it again, and then I have to click on continue. Okay. So this is the old and new values new values definition from the old value, and then you have to click on OK. As I click on OK in the data tab, you can see at the end of the variable, a new variable is created. Just 1 minute. So this is the recorded version. That means females are recorded as 1 and males are recorded as 0. Okay. So a new variable is created at the end of the all variable, and the recorded version is there. And next one is record into same variable. If we click on the record into same variable, that means in the same variable the recorded version will be there. So first of all I have to select the variable. So I'm selecting the gender variables here, and then similarly I have to define the old and new value. So our old value is M, and that is recorded as 0. That means males are recorded as 0 and females are recorded as 1. So I have to add it here, and then I have to click on continue. Click on OK. In the data tab you can see the gender variable is recorded into 0 and 1. Okay. In the same variable the recorded version is there, and from in the different variable the recorded version is there. So this is the record option. So after recording you need to add some labels, like in the variable view. As I told you earlier, this is value option is important when we recorded any string variable into some number, and for adding some labels on that values we need to go for this values option. Like in the gender variable, you can see this is the gender variable, and this is the variable type. This is a string. When we record the variable, it is not in not in string variable. Now it is not string variable, it is a numeric variable. So I have to select numeric and okay. Then I have to put the values label. Okay, so I have to select the three horizontal line, and I have to select this. I have to click on this plus option, and I have to put the values with the label. So our values are 0 and 1. So for 0 is for male participants or male observation, and 1 for female observation, and click on OK. So from the gender variable, in the data tab, from the gender variable you can see, so this is the gender variable, and this is the recorded version of the gender variable. So here one option is there, this is the value label option. You can see 1 to A. Okay, so if you click on that, you can see the label. Okay, so when you click on that, this is the original data, and this is the label of the data. Okay, so this is the value label option. So when we add some labels on our data set, so you have to click on this option so that you can see the value labels. So this is all about record option. After that, frequencies and descriptive statistics. So frequency means to understand how often each category occurs. Suppose you have a data set, you have a categorical data set, and gender variable is there. So I wanted to know that in the whole data sets, how many peoples are male and how many peoples are female. So for that, we have to go for this frequency analysis. So in the SPSS, we will do frequency analysis. Let me show you how you can perform. So in the analysis, and in the analysis option, descriptive statistics option is there. Okay, so you have to select the descriptive statistics, and you have to select the frequencies. If you click on the frequencies, so it is asking me for the variables which were I want to study. So I have to select the gender variable, because I wanted to know how many peoples are male in the data and how many peoples are female in the dataset. So I have to put the variables, gender variables, in the variable box. Then I have to select the statistic. I have to click on statistics, and if you want mean, median, mode, or like this, so if you can add any of those, I'm happy with it. So I have to click on continue. In the charts, you can get some bar charts also. So I want bar chart, so I'm selecting here bar chart. If you want pie chart, then you can select pie chart also, and click on continue. You can format your values on multiple values from format option, and this is the style option. You can change it from here. Okay, so now you have to click on OK. So this is the frequency result. You can see male students, this is the frequency of male, and this is the frequency of female, and this is the percentage, and this is the cumulative percentage. Okay, out of 6400 participants or observations, there are 3221 males are there, and 3179 females are there. And this is the pie chart Basically, pie chart, red one is female and blue one is male. So if you want to, if you want to know the exact labels of the data sets, you have to double click on it, and in the element you have to select show data labels. Okay, then you have to close it, and you can see the actual labels. Then for the male student, male participant or male observation is this, and this is the female observation. So this is all about frequency analysis. So when we do what types of data we have, if we have some categorical data, then we go for frequency analysis. If we have some continuous data like income, height, weight, so those types of continuous data sets, we have to go for uh, descriptive statistics. Okay, so under the analysis, descriptive statistics, and this is the descriptive. So if you have any categorical data, then you will perform frequency analysis to know the basics or know the basic statistics, and this is the descriptive statistics for uh, continuous variable like age or income, height, weight, like this. So in the data set, in the data tab, you can see there is a income variable is there. So now I wanted to know about the basic descriptive statistics of income variable. So I have to perform descriptive statistics on income variable. So under the analyze option, descriptive statistics, and I have to select descriptives. So from there, it is asking me for the variable. So I am selecting the income variables, or I have to drag it here. Okay. Then from the options, you can add those measures if you want. So I want the skewness and kurtosis also. So I am selecting here, and I want variance also. So I have to click on continue. From the styles, you can change the styles also. Okay, then I have to click on OK. So this is the descriptive statistics of income variable. Okay, you can see this is the statistics, and this is the minimum statistics, maximum, mean, standard deviation, variance, skewness, kurtosis, all measures are there. Okay, one more option is there to check the descriptive statistics, as I told you earlier. And in the overview tab, if you click on this update menu, here is the update menu is there. If you click on that, and in the variable report, if you select the income variables, you can get the basic statistics like mean, standard deviation, maximum, minimum. Those types of basic statistics you can get from here also. Okay, so this is all about descriptive statistics. So now we'll move to the t-test, that is hypothesis testing. So in hypothesis testing, there are three types of t-test is there: one sample t-test, two sample t-test, or independent sample t-test, and pair sample t-test. Okay, so what is t-test? So t-test is a statistical test used to compare the mean of two or more groups. Okay, that is used to understand whether the difference is seen in the data real or due to random chances. So we need to check that one. So for example, as example, we can say that you may compare the average weight of the patient in ward A and ward B. Suppose you have two wards in the hospital, ward A and ward B, and you need to check the difference between ward A and ward B. Okay, from or you wanted to calculate some new teaching method, because you have a teaching method, you have some students, okay, you have some students, and you calculate the student test score before a tuition and after a tuition. So you need to check the difference between before and after the tuition mark score. Okay, so for that you need to apply some t-test, and t-test will tell you that the chances are due to random chances or it is significant. Okay, so for that you have to apply some t-test on your data set. So there are two types of hypothesis, that is null hypothesis and alternative hypothesis. So null hypothesis says that or assume that there is no difference, because that means two means are same, that means we have two groups. Okay, so first one is after the before the tuition there is a score, and after a tuition there is a score of some students. So we need to calculate the mean of first group, that means before the student we need to calculate the mean, and after the tuition program we need to calculate the mean of the students marks. Okay, then we check if there is any difference or not. If there is a difference, that means t-test will tell you it is significant or not, or just by chance. So null hypothesis says there is a no difference, or it's assumed there is no difference, and alternative hypothesis assume there is a difference, that means the mean are not equal. That means mu1 and mu2, that is the two different mean, that is not equal. So after running the t-test in SPSS, it will give you p-value. P-value, if the p-values are less than 0.05, that means we can say the difference is statistically significant. Okay, and if it is greater than 0.05, then we can say the result is not statistically significant, it's just random by chance. So there are some assumptions of t-test. So before using t-test, we must check the assumptions. So the assumptions are, first one is data should be normally distributed, and second one is variance should be similar between two groups. The variance should be similar, that is homogeneity of variance, and the scale, that means data must be on continuous scale. That means data must be on continuous, not in categorical data. When we have some categorical data, then we need to apply non-parametric tests. Okay, so data should be continuous in scale. And next one is independence, that means the data should be independent to each other. And last one is no extreme outlier, that means that there should not be extreme outlier. If there is a extreme outlier, then t-test might wrongly predicted, or for that case we need to apply another test. Okay, so for both p values, if it is greater than 0.05, then we can safely use t-test, or otherwise we will shift to non-parametric approaches. So parametric versus non-parametric method. So in parametric test, it assumes first normally distributed data. Second one, we use we use mean for the comparison of the two groups, and it is more powerful than the if the assumptions are satisfied than the parametric test. And for the non-parametric test, we do not need to require some the normality condition, and here it is used median or rank, because it is a categorical data, so we can't apply mean or like this, so we need to use median. And it is robust for the skewed or ordinal or nominal data, and if it is robust if there is some outliers. Okay, so there are three types of t-test that is available in SPSS. So first one is one sample t-test, second one is independent sample t-test, and the third one is paired sample t-test. So first one is one sample t-test. So we use one sample t-test when we want to compare the sample mean with the known hypothesized population mean. That means we have a population mean, we know the population mean, and we need to check the sample mean with the population mean through this one sample t-test. Okay, suppose we can say that suppose we have a data set of uh, some patients, the weight of some patients, and we know the actual population mean, that is 65 kg. Okay, suppose it is 65 kg. So for that we applied one sample t-test, and as a test variable we have to put 65 kg, and after running one sample t-test, it will tell you that the actual mean, that is similar to the 65 or not. If it is similar, then it will say that it is randomly or just by chance, or it is statistically significant or not, by giving in the p value. Okay, so when we have one sample data, and we know the actual population mean, so for that cases we use one sample t-test. For example, here you can see a teacher believes her students scored higher than the national average of 70 in math. So she collected the score from the student and checked the difference through one sample t-test. That means he knows the actual mean of the math score, that is 70. So she wants to check if their students mean, the students mean is similar to 70 or not. So for that she applied one sample t-test and get the result. So this is the t statistics of one sample t-test. So now we have to apply one sample t-test in a data set. So let me open the SPSS. So in SPSS we need to import our data. First we need to import a demo data set that is downloaded in my device. Okay, so we will use this patient datasets .sav. Then we have to click on OK. So this is our data set. You can see there is a the datasets contain 1000 observation with continuous and ordinal and categorical variable. Okay, so you can see word A and word A weight and word B weight. So they are continuous weight of the patient in two words, and before weight and after weight represent the patient's weight before and after the treatment. Okay, and word X satisfaction and word Y satisfaction, that are ordinal satisfaction score, that is calculated 1 to 5, and pain before and pain after, that is ordinal pain score, the data is collected 1 to 10 1 to 10 base, and the dataset is ready to perform independent sample t-test, pair sample t-test, like this. Okay, so now we need to apply one sample t-test first. So suppose I wanted to know this is the word A weight. So suppose I wanted to know that it is we have the sample mean, that is 65 kg. So we need to check if it is different from the 65 kgs or not. So we need to apply one sample t-test. I have to click the analyze menu. Under the analyze menu, you can see compare means and proportion option is there. So under the means compare means and proportion option, you can get one sample t-test, independent sample t-test, pair sample t-test, one way ANOVA, one sample proportion, independent sample proportion, paired sample proportion. So those types of analysis you can do using this compared mean and proportion option. So I'm selecting one sample t-test here, and this interface will pop up in front of you. So you can see this is the test variable. So I have to put, or I have to drag the word a weight in this box, and this is the test value result. So you have to put the hypothesized mean. So I have to check if it is 65 kg or not, similar to 65 kg or not. So I have to put 65 here as a test value. From the option, you can change the confidence interval from 95 to 99. Then you have to click on OK. So this is the one sample t-test result. So here you can see 1000 observation is there, and the actual mean of the 1000 observation, that is 65.1933. Okay, and this is the standard deviation, and this is the standard error. So we put the hypothesized mean as 65, but it is not 65, it is slightly um, bigger than 65. So here is the mean difference, you can see. So here is the mean difference, that is 0.1933. Okay, so here is the mean difference, and this is the statistics, and this is the degrees of freedom, and this is the p values. Okay, this is the effect size. So one sample t-test is conducted to determine whether the mean patient's weight of A, that is differ from hypothesized mean, that is 65 kgs or not. So the sample of 1000 patients had a mean of 65.19, you can see here. Okay, so from the two-tailed or one-tailed p-value, you can see two-tailed and one-tailed p-value is there. From one-tailed p-value, it is the 2.66. Sorry, one-sided p, that is 0.26, and for the two-sided p, it is 0.533, that is greater than 0.05. That means we fail to reject the null hypothesis. That is indicating the average weight in word A is not significantly different from the 65 kg. Okay, and the mean difference is so small, you can see the mean difference is so small. And this is the effect size. So this is the effect size point estimate, this is the effect size 0.002. so we can see this is very small effect size, that is suggests the difference is negligibly or negligible in practical terms. The difference is negligible. Okay, so this is all about one sample t-test. So next one is a paired sample t-test or independent sample t-test. So for the independent sample t-test, we use the independent sample t-test when we have two independent group. Okay, so when we have two independent group, and suppose we want to see if the difference between the math score between male and female. Okay, so in the previous one we have draw a example, that is a teacher is collected the data of the her students, So from the students there is two group, male and female. Two different independent group is there, male student and female student. Okay. So now you want to know that there is any difference between the male score of the student and the female score of the student. So for that you have to apply one independent sample details, because there is two independent group and we need to check the mean of the two independent group is differ or not. So when we use it, so when we have two independent group like male and female, next the dependent variable should be continuous. So it's not it should be continuous, that means it is not in categorical form like first or second like this. Okay, so it should be continuous, and we need to check the normality first. Okay, so we need to check the normality and the other assumptions. If the assumptions are made, then we go for independent sample t-test or any t-test. So before the independent sample t-test or sample t-test, independent sample t-test or one sample t-test or pair sample t-test, first we need to check the normality. If it is normally distributed data, then we will go for independent sample t-test or any types of t-test. So you can see this is the t statistics value formula. Okay. So for next one is pair sample t-test. So pair sample t-test, uh, when we use it, when we have the same subject that is measured twice. Okay. So like before and after the invitation. For example, we can say students scored before and after a teaching program. So here each student take a test before the program and another test after the program, and the pair sample t-test compare the difference in score for the each student to see the uh, teaching program is statistically significantly affect the students or not. Okay, so the formula is calculated like this. You can see it from here. So we need to check if there is difference between the before measures and after measure, so that we can understand. So for that we have to perform pair sample t-test on the same data set. So we need to open the SPSS. This is our data sets, and we can see this is before weights and after weights. So before weights means there is a treatment method, and before the treatment we have collected the data, and after the treatment we have collected the data. Now we want to check the treatment effect is affected the uh, patients or not. So we need to check the difference, mean difference actually. So for that we have to go for this analyze option, and under the analyze option and compare means and proportion, we have to apply paired sample t-test. So this is asking me for the variable 1 and variable 2. So I have to put the before weight as a variable 1 and after weight as a variable 2. I have to put it here. So our before weight is variable 1 and after weight is variable 2. If you go with the options, so you can change the confidence interval from here also. Then you have to click on continue and you have to click on OK. So this is the paired sample result. So you can see the number of observation is there, and this is the correlation. The correlation between two variables before and after weight, there is some correlation. So this is the correlation, and this is the mean, this is the standard deviation. Okay, that mean means mean difference actually. This is the mean difference, this is the standard variance difference, Okay, and this is the significance level. So you can see alls are less than 0.05. So when it is less than 0.05, that means if it is that means if the p values are less than 0.05, the difference is called statistically significant. So you can see this is 0.05, less than 0.05. So we can say the difference is statistically significant, and this is the t statistics value. From the t table also you can get the results, and this is the pair sample t test effect size. So effect size is 0.99555. That means the effect size is very big. So practically we can say there is a big difference. Okay. So in the gist, as a gist, we can say that treatment program affect the patient to decreases their weight. Okay. So this is all about pair sample t-test. If you want to learn independent sample t-test, then you can go with this help menu. One help menu is there in SPSS. To in analyze menu, there are many more analyze is there. If you want to learn any of the analyze from there, you can go with this help menu. Help menu is there, and then you have to click on the topics. In the topics you can get the case studies. Okay, in the case studies you have to select the base edition, and then you can get the all types of tests and analysis. Okay, suppose I wanted to learn independent sample t-test, so I have to click on t-test. So basically I wanted to learn independent sample t-test, so I have to click on the independent sample t-test. So here they have explained what is independent sample t-test. They mentioned case studies with the sample files. Okay, so this is the sample files. You can find it from here in SPSS. With the sample files, they have taken a case studies, and they have also provided some step-by-step guidance with the snapshots, how to perform, how to run the analysis. Okay, they have also explained the output here. So if you want to learn anything, you can go with this IBM documentation site by clicking this help menu. Help menu is there. By clicking the help menu, you can get those types of sites. Okay, and you can learn anything. So for this session, I'm done for this session. If you have any doubt, please let me know.
So participant have any questions? You can raise your questions, please.
One queries is there in chat box. So can the t-test be used for all categories? No, sir. If it is categorical variable, I told you earlier that there is some assumptions for the t-test. So first we have to check the assumptions. If it is made, then we can do t-test. Like the assumptions are, first you have to check. Sorry, you have the data should be continuous data, not categorical data. If it is categorical data, then we need to apply non-parametric tests. Okay, so if it is t-test, then the data should be normally distributed and continuous. Is there any doubts?
So any doubt? You can raise your doubts with our expert. I think Mahanta sir, the scholar as we also have to run the test. Then there will be various queries. Once
Hmm.
we will work
At
on this, then there will be queries because it is
Yes, sir.
new
Yes,
for
sir.
most
At
of us,
the
right?
second session, we will do some hands-on work, sir.
So
Okay, sir.
there is a question. What is the maximum sample size to apply t-test?
No, ma'am. No, sir. There is no maximum limits. If it is 1,000 observation or if it is 2,000, 3,000, you can do it.
Okay, fine. So will you take a break for 5 minutes?
Yes, sir. We'll take a break and we'll start the next session from 4:15. Okay.
Okay, 4:15, right. So please try to finish that session on or before 4:55, right? So 5 minutes for
Okay.
the question answers.
Okay, sir.
Is it possible?
I'll try, sir.
Yeah, fine. So participant will wait for the 5 to 6 minutes, and so please be on login and mute your mic. So we'll be back after 4:15.
Hello everyone. Welcome to the second session, that is on regression and survival analysis and the hands-on practice. Hello sir, can you hear me? Hello.
Yes, sir, we can hear you. Please continue.
Okay. So today our main topic is regression. So what is our first question is, what is regression? So regression is a supervised machine learning algorithm where the inputs and outputs both are known to make the model. So regression is basically a method to study the relationship between the variables. Okay, so we use it when we wanted to find any one new thing that changes the other things. So there are two types of variable. One is a dependent variable and another one is independent variable. So dependent variable means we can think it as a result or output, and for the independent variable we can think them as a reason. Okay, so for example, we can say there is uh, predicting the crop yield from the temperature and rainfall. We have three variables. We have the data for the previous year's crop yield, and we have the data for the temperature and rainfall. Now we will perform regression on those data sets to predict the upcoming seasons crop yield. Okay, by using regression. So there are some basic assumptions for the regression. So before we can trust our regression model, we need to check those assumptions. So this is first one is linearity. Linearity means the relationship between the predictor and the outcome, means the dependent and independent variable should be for roughly followed a straight line. And the second one is normality of residuals. That means the residuals of error, that the difference between the actual value and the predicted value should be followed normally distributed. And third one is homoscedasticity. That means equal spread of the error throughout the all the area of the data set. Okay, and the fourth one is independence. That means the observation should be independent of each other and it stands on its own, not affected by others. And the fifth one is no multicollinearity. That means that independent variable should be if it is highly correlated, then it should be it will create a problem for the analysis. So it should not be highly correlated to each other. So how to check those assumptions? We can check the linearity using the histogram plot if it is continuous variable. For the normality, we need to check the histogram. For the linearity, we have to plot the scatter plot. Okay, we have to plot those data, and we need to check if it is roughly straight line or not. For the homoscedasticity, we need to check the plot of the residual and the actual value. For the independence, we need to check with some results or with some uh, test And for the multicollinearity, we need to check VIP factor. You know all about the VIP factor means if it is less than 5, VIP is less than 5, then we can say there is no multicollinearity present in the dataset. If it is from between 5 to 7, then we can say mild multicollinearity is present. If it is greater than 5, then we can't go for normal linear regression. Then we need to perform ridge regression or lasso regression. Okay. So in this demonstration, we will cover multiple linear regression. So multiple means more than two or more than one. So in simple linear in regression, there are two types of linear regression, that is simple linear regression and multiple linear regression. If there is one predictor, then it is called simple linear regression. If it is more than one predictor, then we can say this is a multiple linear regression. So most of the cases in real life, outcomes are usually affected by many different factors, not just by one. So this is where the multiple linear regression comes in. So this is the formula of multiple linear regression. Y, that means we need to predict the y. This is dependent variable, and A is the intercept, and B1, B2, and Bn, that is regression coefficient and slopes, and x1, x2, and x3, and xn. This is all about the independent variable. Okay. So after performing the regression, we need to check adjusted R square, beta coefficient, and more the outputs. So why the multiple linear regression we use? First of all, we need to study the several factor in same time, and we need to check the combined effect and the individual effect. Okay. And for example, we can in this demonstration we'll import a data set, that is a card data set. So let me open the SPSS to perform multiple linear regression. So for to perform this to perform the multiple linear regression, we need to import a data, that is card sales.sav data. This is the card sales.sav data. So this is the card sales and card sales data. So in this data sets, we want to know what want to predict the card sales, but this time the price is not only the factor. So price is a factor. We include the price, engine size, and the horsepower. As the variable view, you can see this is the manufacturer name, this is the model of the car, and sales in thousand. This is the dependent variable for ourselves, and the price in thousand, engine size, and horsepower. Using these three variables, we need to predict the sales of the car. Okay. So in multiple linear regression, we need to predict the cars of the sales of the car. So for that, we have to go for this analyze option. Under the analyze option, you can see there is a regression option is there. So under the regression option, you can find all types of linear regression and linear alternative OLS alternative. That means we told you earlier that if the VIP is greater than 7 or it is greater than 10, then we can't go for linear regression, because there will be some problem later. So for that, we have to go for ridge regression, lasso regression, or elastinet regression. Okay. So those types of regression are there, Ridge, lasso, and elastinate. And this is the curve estimation, Ridge regression. All types of regression are available here. So in this demonstration, we will cover multiple linear regression. So I have to click the linear regression, and this is asking me for the dependent variable. So dependent variable is those variable whichever we want to predict. So for the example, for this example, we need to predict the car sales. So I have to put the car sales in dependent variable box. Okay, and this is the independent variable. That means we want to predict the car sales using which variable? Using price, engine size, and horsepower. Okay, we want to use those three. So I have to put it here in dependent variable box. So this is the independent variable box. This is the independent variable, and this is the method. You can choose any of those. I'm selecting normal here, and this is the statistics. If you want those types of statistics, you can add any of those. Okay, this is the plots. If you want any types of histogram plots or residual plot, normally probability plot, you can go with this. This is the safe value. That means regression. If we build a regression model, then regression model also predict those previous value. Okay, by using the regression model. So if you want to save those predicted values, so you can choose a standardized. This is the unstandardized predicted value. This is standardized predicted value, and this is adjusted value. So I want standardized predicted value, so I'm selecting here. And this is the residual means suppose we were by using regression we predict a student score. Okay, so we predict a student score. So using regression and the previous data, like how many hours he read the books, how many classes he attend. So those types of information we have, and using the information we make a regression model. And regression model tell us that he will be scored 80%. Okay, he'll be scored 80%. But actually when exam come and the student appear the exam, and after that we check that the student scored 78%. So there is a difference between the actual value and the predicted value. So that is 2%. So this is called residual. If you want the residual in your data tab, so you can select any of those. I'm selecting here standardized residual, and this is the distances. If you want, you can select any of those. Okay, so I'm selecting here continue, and this is the options. You can choose any of those. So after that you have to select OK. You have to click on OK. So this is the regression result when we perform regression. So there is two main result for interpreting the regression, that is R square and coefficients. Okay, so coefficients means when we share the PPT, you can see the B1, B2, and Bn. Those are the coefficients, and here in SPSS, this all the sum of square and mean, and this is the coefficients. You can see this is the coefficients for three variables. This is the coefficient, and this is a constant term. That means in the regression equation you can see a, that means intercept. This is the value of intercept. So here in the coefficient table, so this is the intercept value 71.163. Okay, so this is the intercept, and this is the coefficient value, and this is the residual statistics, and this is the model summary. So R means this is the
एक तो दिव्या मैम को देना है और
hello.
एक उनको देना है आंटी को
हम दोनों मैं सॉरी कर रही हूँ कितना बचा
Okay, so R means there is this is the correlation between the dependent variable and independent variable, and at the R square and adjusted R square means R square means how much the we build a model using the data points. Okay, so after that adjusted R square or R square, that is tells us the how well our model explain the data. Okay, how well our model is, actually how well our model is, that is tell us using with the R square. So here you can see R square value is 0 to 1. So if it is nearly 1, then we can say that our model is very good. If it is nearly 0, then we can say it is not good, we need to add more variable. Okay, so for this particular analysis we can see 0.18, that means 18% good. Okay, this is not a good model. So we need to add more relevant independent variable, like in the data sets you can see there is more variable, more information about the card, that is wheelbase, width, length, card weight, fuel capacity, fuel efficiency. So if we all add all the variables in our model, then it will be better. Okay, so this is the R square and adjusted R square, and this is the ANOVA table. This is the coefficient, as I told you. So those two tables are most important to interpret the results. So this is the model summary and coefficients. Okay, so next one is logistic regression. Sorry. So for the logistic regression, if you have some categorical data, okay, if you have some categorical data, that is dependent variable, so for that case you need to apply logistic regression, because normal regression will not predict the value. Like you have some data, you have some student data. Okay, how many hours he read, how many classes he attend, how many books he read for the one subject. Okay, those types of independent variable you have, and you if you want to predict, if you want to predict his he will be pass or fail in the exam, not the actual exam score. Okay, not the exam score. If it is if you want to predict the exam score, then you will go for linear regression. If you want to predict the sorry, if he is pass or fail, then you have to go for this logistic regression. And the output for that, you have to interpret the result, you have the odd ratio, that is change the odd per unit change in x, and you got the p values also significant. If it is less than 0.05, that means we can say it's a significant difference. And you can get the classification table also in SPSS. Okay, so here in SPSS, from the analyze menu, and regression table, binary logistic regression is there. Okay, binary means there is two types of output, either he passed or failed. Two types of output. If it is three types of output, then we need to perform multinomial logistic. Okay, so I want binary logistics, so I have to click on it, and you have to put the dependent variable. This data is not for logistic regression. We have to import another data. So if there is a dependent variable and there is a covariate, so first of all we need to import another data. So in the sample file there is a data called bankloan.sav. There is a bankloan.sav. Then you have to click on analyze. So here in the data set you can see there is a data set for the bank customer details. Okay, so bank gives us give them loan and records their data. Okay, so I want to predict if their bank gives them loan and they calculated if they are default or not. If it is yes, that means he took a loan and he becomes default. Or if it is no, that means he paid. That means he is not default. Okay, so now by using logistic regression, we need to perform the probability of the defaulty of the customer. Okay, so for that you need to go for analyze. Under the analyze, regression option is there, binary logistic, and our dependent variable is, oof, wait a minute. So our dependent variable is he is previously defaulted or not. This is our dependent variable, and this all are our independent variable or covariates. This is called covariate in the independent variables are called covariate. So for that you have to go for this categorical. So among the covariates, if there is any categorical variable, then you have to put it here as a categorical covariates. So this is the categorical covariate, education, level of education. So I have to put it here and click on continue, click on OK. So this is the logistic regression result, and here you can see the expected betas, that is this is the expected beta, that means odd ratio, and this is the significance level. Okay, and this is the classification table, and this is the model summary. Okay, so now we will perform Kalpan-Meyer survival analysis. So what is Kalpan-Meyer survival analysis? So Kalpan-Meyer survival analysis is a descriptive method to use the study the time until the event occurs. Okay. So for the medical research, it helps us to recovery of the patients. In business, it helps us to for the customer who purchase first purchase. Okay, so it helps us to show how the probability of an event change over the time. So the key terms for this analysis is first event, that means the incident or the outcome of the interest, and censoring means when the event does not occur during the study end. Okay, that means it is called censoring. For the example, we can say the patient leaves the trial before the recovery, that is censoring, and the smartphone still ringing at the end of the study, that is called censoring. And in Kalpan-Meyer survival analysis, it allows you to examine the distribution, study of the subgroup, and for example, we take the dataset as the pain.medication.sav. In these datasets, we have to perform the Kalpan-Meyer survival analysis. Okay. So in the SPSS, we need to import the data first. This is the data sets. So we need to import the data sets. To perform the Kalpan-Meyer survival analysis, you need to go for analyze and the survival. So there is three types of survival analysis that is available in SPSS. First one is life table, Kalpan-Meyer, and Cox regression. In this particular demonstration, we will cover Kalpan-Meyer. So I have to click on Kalpan-Meyer, and this is the variables, and it is asking me for the time variable. So I have to drag it here as a time variable, that is time to effect. In the status variable, I have to put it the effect status, and I have to I have to define the event. That means 0 and 1. 1 means it's the event is happened. 0 means if the event is not happened or censored. Click on continue. As the factor, we have to choose the treatment, and I have to click on this compare factor, and I have to select the test statistics as log rank. If you want those, you can select this. Then you have to click on continue and OK. So this is the Kalpan-Meyer survival analysis result. So here you can see this is the survival table. So there is two drugs, and one is new drug and another one is existing drug. For the new drug, there is 104 cases is there, and for the existing drug, there is 96 cases is there. And in this survival table, you can get the time to take event, that is time, that is cumulative time, and this is the number of cumulative event occurs on that time. Okay, and this is the status, that means new drug is taken or not, or taken the effect or not. So you can see this is the cumulative time, that is 11.6 to take the effect of the drug, and this is the existing drug, and this is the total cumulative time 11.3. The previous one is 11.6, that means there is no bigger difference. And this is the mean and median for the survival time. So Kalpan-Meyer analysis compared the survival experience between new drug and the existing drug group. So the mean of the survival time of the patient receiving the new drug is, you can see, 4.8 867. Okay, while the existing drug group had a slightly higher mean, you can see here 5.185. Okay, and the median of the survival time is 3.7 until the new drug, and 4.1, that is units for the existing drug, and that is indicating a small numeric difference between those. And the statistical difference is there in survival distribution between two treatments. Okay, so this is all about survival analysis. So now this is all about this second session. Now we will do some hands-on work, and if there is any doubt, please let me know. Hello sir, can I hear can you hear me?
Yeah, Mahanta sir, I can hear you.
Okay, sir. So now
So,
it's time.
so please let me know one thing.
Hmm.
Actually, what happened? So we have procured 10 licenses only.
Hmm.
Okay. These licenses are not distributed to the student and faculty members so far. Uh,
Okay.
So these are installed in the libraries only.
Okay.
Okay, so a student may not be able to do the hand-on practice right now.
Okay.
Yeah, so this is for your kind information. So they will do it later.
Okay, sir. Okay. Then if anybody have any queries or any doubt, please let me know.
Sir, I have a question. Am I audible?
Yes, ma'am. You
Sir,
are.
you said if p value is greater than zero point 0.5, so
Hmm.
there will be some statistical difference. And you
Hmm.
also quoted that there will be significant difference. So I am little confused between statistical difference and significance difference.
No, two terms are similar, ma'am.
Okay.
Statistically significant difference.
Okay, sir. Okay.
Yes, yes,
Thank you. Thank you, sir.
yes.
So any other query, please? So anyone have any doubts?
I'm dropping my mail in the chat box. If anybody have any problem during the hands-on, please raise a mail. Okay.
Sure, sir. Thank you. So once again, scholars and faculty members. So we have procured 10 licenses of the SPSS, and out of the 10, 4 are installed at the Central Library, Srinagar, and 2 each are at the Chauras, Podi and Tehri campus libraries. So if you want to use the SPSS 31 version, so please contact the in charge of the respective campus libraries. So he will help you, and please try to use it. And so if there is a query, you can write to me, or you can directly write to the Mr. Papu Mahanta sir. So he will going to help you. So any other question? Dr. Joshi ji, would you like to add something?
No. Okay, everything is okay.
Okay. Papu Mahanta sir, would you
Yes,
like
sir.
to add something, add on? Would you like to add something else?
Okay, sir. Is there any doubt, sir? All
Uh,
doubts are clear, na?
No, no. See, no, all doubts are not clear because, as I already mentioned, that see, this is first
No, no,
time we have procured the SPSS for our university, right?
no
So,
problem, sir. No
yeah,
problem. If
so
in future,
it is new for even me, even I'm sure it will be new for the many scholars also.
okay, sir. No problem.
Okay,
If in
yeah,
future,
so
in
yeah,
future, if you feel any problem, just come to us. Okay.
definitely, sir. And one more request, sir. Please share the recording of the this session so that I will share
Okay,
it
sir.
to
Okay.
our faculty members and the scholars, and
Okay.
it will definitely going to help them. Okay, because it is a vast, 2.5 hours training. It is vast, and you have covered a lot of things, and even lot
Hmm.
of things are yet to be covered.
Okay, sir. Okay, sir. No problem. It will be shared.
Yeah, right. Thank you. So now I would like to thank you all the faculty members, my colleagues, and all the research scholars, and even the resource persons, see Papu Mahanta ji, for his detailed descriptive analysis of the SPSS 31 version and various types of the t-test and regression analysis. So it was very interactive and very informative session. Thank you so very much, sir. Thank you everyone for joining this session and making this event more useful. Thank you very much.
Thank you, sir. Have a
Thank you
good
so
day.
much, sir.
Thank you.
Thank you to everyone. Thank you, sir.